Hello, good day viewers. In our previous lesson, I have shown you how to derive these important formulas for the composition of inverse trigonometric functions in the main trigonometric ratios. So today we are going to apply them in evaluating some problems here. You can see them right here. All right, let's get started with the first one. We would like to evaluate the sine of the cosine inverse of 1 over 2. Remember, I told you that once you can recognize that angle, because cosine inverse of 1 over 2 here represent an angle, so we are looking for sine of that angle. But you can only recognize spatial angles. Once the angle is not spatial, this is why the formula is very important. So for instance, cosine of what angle is 1 over 2? This is what this is saying. We know that it is what? Cosine of 60 degrees, because cosine of 60 degrees is 1 over 2, right? So the whole of this is 60 degrees. And sine of 60 degrees will give us root 3 divided by 2. So once you can recognize that angle, you can apply that always. Well, let's see whether it is going to give us root 3 divided by 2 once we apply the formula. So you should know that x here stands for 1 over 2. So wherever we have x here, we're going to replace it with 1 over 2. So this is equal to the square root of 1 minus x squared, which is 1 over 2 squared. This is equal to the square root of 1 minus 1 squared is 1, 2 squared is 4. Once you subtract 1 over 4 from 1, you're going to get 3 divided by 4, right? So this is square root of 3 divided by 4. Then you take the square root separately, square root of the numerator over the square root of the denominator. Square root of 3 remains square root of 3. Divided by square root of 4 is 2. Can you see that? We are able to obtain root 3 divided by 2, because I told you this is 60 degrees and sine of 60 degrees is root 3 divided by 2. Therefore, the formula is applicable. Let's go to the next one. Once you have cosine of tan inverse of something, you can see the formula here. Cosine of tangent inverse of x is equal to 1 divided by the square root of 1 plus x squared, for which x is 1 here, right? So let us evaluate it. So the question is, tangent of what angle will give you 1? It will be tangent of 45 degrees. And cosine of 45 degrees is root 2 divided by 2. It means that this angle is spatial. Once it is not spatial, you cannot do it this way. So let us apply the formula. This will be equal to 1 divided by the square root of 1 plus x squared, which is 1 squared because x is 1. This is equal to 1 divided by the square root of, this is 1, 1 squared is also 1, so we have 1 plus 1, which is equal to 2. From here, you can rationalize the denominator by multiplying the top by square root of 2, the bottom by square root of 2. You know this is naturally equal to 1. So we have to the top 1 times square root of 2 is square root of 2. The bottom we have square root of 2 times square root of 2, which is square root of 4, which is 2. You see that? We are able to obtain square root of 2 divided by 2 as cos of tangent inverse of 1. Let's move on. But you know that this angle is not spatial, because I don't think we have any spatial angle which if you take cosine of that angle, it will give you 1 over 4. So in this case, you cannot do it mentally. Let us apply the formula for which x is 1 over 4. So this is equal to the square root of 1 minus x squared, which is 1 over 4 squared. And this is equal to the square root of 1 minus 1 squared is 1, 4 squared is 16. As simple as that. This is equal to the square root of 15 divided by 16. All right. Square root of 15 remains square root of 15. But square root of 16 is 4. And hence, this is our final answer. As simple as that. Let's move on to the next one. We like to find the cosine of sine inverse of 5 divided by 13. This is not a spatial angle as well. So we use the formula for cosine of sine inverse of x, for which x is 5 divided by 13. So this is equal to the square root of 1 minus x squared, that is 5 divided by 13 squared. This is equal to the square root of 1 minus 5 squared is 25 divided by 13 squared is 169 If you subtract, you're going to get 144 divided by 169 under square root. Square root of 144 is 12. Square root of 169 is 13. This is our final answer, as simple as that. If you don't know how we derive these formulas, you can watch the previous lesson. And here we have tangent of cosine inverse of 2 over 3. This is not a special angle as well. So we use the formula. This is equal to the square root of 1 minus x squared minus 2 over 3 squared, right? Divided by x, that is divided by 2 over 3. This is equal to the square root of 1 minus 2 squared is 4, 3 squared is 9. I would like to use this division sign, 2 over 3. This is equal to the square root of 5 over 9. That is 1 minus 4 over 9. Then I can change this to multiplication and take reciprocal, 3 over 2. Right? Square root of 5 is square root of 5. Square root of 9 is 3. Times 3 divided by 2. You can see that 3 and 3 will cancel. What do we have left? We have square root of 5 divided by 2. Simple. So I think, let me give you another one for you to try. Cosine of, let me generate something here very nice. Okay, let me take sine inverse of 5 over 7. I want you to evaluate this and drop your answer in the comment box. Bye-bye.